Alright, well, we're going to be streaming some game development today. So it's going to be a bit of a calmer stream. So I'm not probably going to be talking a whole heck of a lot, unless people have questions or something else like that. I'm just going to be working on setting stuff up, so that's just what we're going to do. Let's see, what are we setting up? What is the first thing we're doing here? So, the base classes. All of the things. So, we're making this movement controller. Let's just start splitting stuff up. Just got the movement components. Yeah, we're gonna need to move this movement component in here. Let's see. Movement controller component used to go into here. And we'll just reconcile that directory and move all of the things. So yeah, it's not going to be a super talkative stream unless people are actually doing stuff. I'm just going to be showing off the creative process for anybody who wants to watch, because there have been a few requests of, well, stream your game development. So it's going to be just a lot of nuts and bolts setup, but that's just how it is. So people can come back and watch and laugh at all my stupid programming mistakes and make fun of all my braces and indentations and how I set things up all broken and call me a moron. It'll be good. So just moving stuff around. Always kind of a pain in the butt to move things around when you're working with Perforce and the rest. That's what we're looking for. Moving our movement component inside of that movement folder. So what do we got? We got this big diagram here that I was working on earlier of our movement controller. Kind of what we want the movement controller to do is it's going to move the character through the world and make sure that like the proper animations and everything else are playing for it. We got some movement types, and we want to figure out how we actually want to control the movement. So we got like flying movement, we got physical movement, we got locomotion movement. Physics should be like stuff that, boulders that roll down hills, things like that. Flying movement would be just some character who's flying around, doing that sort of stuff. Locomotion would be like Bitey running around, like Mario or whatever, where somebody actually walks and runs and does all that sort of stuff. And then I'm going to figure out how we're actually going to input our controls. So all the other, like the brain is going to say things like, well, I want to move in this direction at this speed, and then the movement controller is supposed to basically figure out how to make that happen, so we can kind of make it easy to write the logic. So it's like, hey, I want to go over to that corner of the room, and the movement controller can be like, well, okay, well, you said you want to go to the right, and you're on the ground, so we're going to start walking in that direction at your walk speed, and we're going to make sure you can actually walk, and if there's a slope, we'll walk up or down that slope. And we'll play your walking animation, so your brain doesn't have to say, well, I want to walk and play the walking animation and all this other crap all in one spot. So hopefully it'll be a little bit easier to make, that whole thing. So we'll see how it goes. Yeah, right now we really don't have a whole heck of a lot going on right. We're very early in development of this game. Let's go ahead and compile this thing up. Compiling is always my favorite part of working on a C++ project. We're going to need to set up a lot of things today, because we've basically just been trying to figure out, since neither Adam and I are Unreal 4 experts, we've been trying to figure out how to get Unreal to work for us and not against us. How we should be setting up assets, how we should be doing everything like that. And it's been tricky, seeing as, because I'm a server engineer by trade, so that's what I've been doing for the last million years. And that's not gameplay, and I've been a little bit farther away from the actual gameplay code than a lot of game developers. So while I have worked in Unreal 4 before, it's mainly kind of the pieces and parts surrounding the actual game, not the actual game itself. So, and we switched over, like we had been using Unity. I had been using Unity for some other projects, and I switched over to Unreal because we want some shaders and some other stuff like that. And it's kind of a trade skill. Both Adam and I kind of found a common vein where we're both like, yeah, I really want to know more about Unreal. And some of that has to do with it's just kind of a more marketable skill in the professional world. If you want to go join a bigger project, which there's more people on larger projects, so there's more jobs on larger projects. So if you want to, put food on the table, knowing Unreal is a really good idea, because there's just a lot more jobs for it, because, well, it kind of follows and all that. So we wanted to learn that. So right now our test level is absolutely, you know, beautiful. We have a single fat sack here doing his fat sackery, which is an actual entity actor. He's actually kind of the first one we set up that it actually does all the things kind of how it should. It's real rough, but like we've got his animation stuff kind of rigged up a little bit, and I can just pop open the collision for him so you can see some basic collision stuff going on. But so he's kind of what I'm starting with. Is just a simple character doing all the things. Maybe I should actually subscribe to Spotify so I don't have all these freaking commercials. But we will see. So we've got Fat Sack running around. So at the moment we really don't have much. Like we hit play, we have a player proxy spawn the main character who is right here, Fat Sack, and we can just move him around and the camera kind of follows him, and you know it's very debug. It's nothing's really here yet, so that's what we're working on changing at the moment, is making it so when we go in here that the character is moving around, and I can change how the camera snaps and all that. So at the end of this, we should have absolutely nothing actually working. We'll just have our C++ classes set up so that we can actually go do something with it. Because right now, it's basically, we got a virtual controller attached to our, I'll throw up our character diagram. Right now we got our Dashkin actor. He's in the actual game. And we got a flipbook attached to that actor. And that flipbook has all the sprite information. So that's all the information that for drawing the thing. And we got the physics information. And physics is, your hitbox, your physics box, all that stuff. Got some entity data, which contains all the character animations and what should be playing at what time. An animation controller component, which basically when we say play the walk animation, it's going to go, get the flipbook set up properly to actually play that. We got our logic controller, which doesn't exist yet. We'll probably, hopefully, be getting to creating the nuts and bolts for that. Logic controller is your brain. It's, what the character is going to be thinking about, what he's going to be doing. Movement controller is going to be, what actually moves our character through the world. And, yeah, we got our virtual controller here. So a virtual controller is basically like, we have our player proxy, which actually grabs like our keyboard input and is going to shoot it over into our virtual controller on this entity. So basically our player proxy is the player, which is kind of the camera, kind of like if you're in Mario 64, you got the lax 2 following you around with the camera. That's actually you, the player, in the game. And this virtual controller is just so like any entity we could just like start piping input to and make him do stuff. So in that way we can kind of jump around and control what we want to in the game. Like if we want to assume control of a fat sack or bitey or a prowly or something, that's kind of how we'll do it. But we're working on setting up the movement controller first, so let's go ahead and start messing with that. Let's just make sure we got everything checked out. What am I doing? I can just do this. This is the first time I'm kind of trying to stream C++ development, so if I'm really boring or don't even get anything done, well, that's not to be entirely unexpected at the moment. So We'll see how it goes. Alright, so we're gonna have... Here's the movement object that's in base. Alright, so the movement object's gonna get updated. So let's fill out basically kind of what we want you to be able to do with this thing. So the movement controller component is going to expose the movement object, which we are not exposing. So we're going to go ahead and do that. So we want it blueprint callable. Let's see, Dashkin get movement. It says you get our movement object, and what do we actually want? Blueprint callable, so the proper one we're doing. So what do we want for interacting with this? We're going to want to do, set one a direction. I'm going to take a const vector. And we're going to take a velocity. We could just do a couple of these guys. Let's worry about exposing these to blueprints kind of after we're done with them. So if we have a one in direction, we're going to want vector and one in direction and one in velocity. We'll probably have it so kind of bitey, and the rest there is going to be controlled by like setting which way you want to go, and maybe the AI and the rest will be kind of more set up with setting where we want to be. So it'll be like bitey's going to want to go right, but maybe an AI person wants to go over to a specific location. So we're going to want a location, we're going to want a velocity for kind of trundling over there. That seems pretty decent. Let's see, we're going to want to do jump. So we're going to give call jump. I'm going to call it with the velocity as well. Alright, so we're going to need a locomotion type for these things. So we'll need getters and setters for that. Let's see, this is should be D. Dashkin movement type. We're going to do MT none. Physics. MT flying. And MT locomotion. So we're going to have void set locomotion type. Let's have a getter for it. Let's see. Virtual update. Let's just have some different update functions in here. Update flying. Motion. So that's going to be kind of, how do we do these? So call to jump. Let's also have some nuts and bolts for these objects. We're going to want kind of a collection of physics attributes, which we can set. So we probably need a kind of a use struct of some basic information on our limits for this entity. Well, whatever. Let's just start simple and then we'll build it complex later. Set maximum velocity. Let's also have some like very specific functions. Like let's have set position. And like set velocity and all that. That's not a vector. It is a vector. What am I talking about? So let's also have some getters for those. This is just to make it simple for other things, because there are ways to get your position and velocity and whatever, but we kind of want to do all of our own here. Let's do a reference example in case we want to know. So we're also going to want to have like a previous, let's see, like previous position, and like a previous position and like a previous velocity. I could see how that could be useful. Yeah. Alright, so we got some basics. What else do we need? Velocity thresholds. Let's get some states. So we're gonna have some kind of movement states, like what's actually happening. So to your character. So we could have like this be a movement state, nothing. Let's see, movement state. We should have a should do like a flying. Movement state. Yeah, I should definitely like go ahead and get Spotify if I'm gonna be using it, because those commercials are freaking annoying as hell. We need some movement states. There's gonna be trying to get like these movement states where we're gonna be accessing them from logic and be like, well, if I'm sliding on something, then I want to be doing something else, which is interesting. So we've got movement state sliding. So we're like on the ground, sliding around. So we have stationary. Not like pencils, but like, see, just normal moving. So this will be like you're on the ground, running. Movement state, let's see, rising. Let's just do air rising. So you're moving through the air, but you are rising through the air. Let's see, air stationary. And then MS air falling. Well, we probably have a few things. So I guess sliding would also be like you're sliding down a wall, kind of like Mega Man. So I don't think we need anything too crazy other than that. So we're also gonna need to be able to fetch the movement state. So let's go ahead and do that. So we're also going to need a movement type. On here. So we have our previous position and velocity. So we're going to need getters for those. Get previous velocity as well. And again, we'll do some reference ones there just for convenience sake. Is there a zero vector? That's not what I want. Let's just look that up real quick. So there is a zero vector. Alright. Let's see. Default movement state should be. Let's just say none. Our default movement type, again, we'll just do none. Well, let's start filling out some of these functions. Whole bunch of boring, but we gotta do boring because you just have to. Yeah, C++ development's a whole bunch of just typing a bunch of crap out and seeing how it goes. I'm actually going to go ahead and do a couple things real quick that I'd rather not have on stream. Which is upgrading Spotify because I never got around to it. Alright, now we shouldn't be interrupted with more commercials for Lowe's. So Lord knows I should probably get outside more. Starting to look like a ghost down here in this basement. That's just how it is though. This is a wrong file, isn't it? We want to be working on the movement object, not the movement component. What the hell are we doing here? We'll just fix this. And let's start filling out all the things. Right now I'm just gonna throw in some trace logging just so we know things are working when we get it working. I wrote my own log macros. If anybody is interested in those, just let me know and I can answer your questions about them. Updating with locomotion-based locomotion. It's all about that locomotion. So we're going to call set position. Later we'll probably actually be doing some crazy stuff. Should we make an internal set position? Because basically we'll wrap all the rest of our set positions there, so it sets like your previous position and does all the things. So let's see. Yeah. We're gonna need to get the position off of the actor itself, aren't we? So why don't we just go do that? So we're gonna grab our transform. Do we have the actual? This is a movement object, so we actually do have this. Because we'll probably have some checks in here to see if like you're trying to move somebody in the middle of a wall or something, which just never works. So we will see. We will see. Alright, so we're setting that position, and we're going to set our actual position here. Let's also add some trace logging, because we're just working on this. Just because we can. Alright, so M-Actor should be on our dude. Let's just go double check. And he is there. And as with anything, if M-Actor is null, let's just get the hell out of here. So that's going to be our internal set position. So we're going to kind of scroll that away down at the bottom somewhere, so we're not looking at it all the time, because we don't always need that. Alright, so we're going to call set velocity. Yeah, set position needs to call internal set position. That position. So setting our velocity. We don't actually have a real velocity thing here, do we? So we should probably make one. Let's make a current velocity. And that reminds me, I put all the MIL stuff over here before, so let's go snag it. I put the commas at the beginning just so, whatever. Just because of habit. So, M current velocity equals velocity. Setting new velocity. Gotta love velocity. So let's get our position. Right now, I'm just going to get it right off of the transform. I think that sounds like the best plan for us. And we could just be like, hey, if you want to get the position of your actor, just call get position. But I might have some weird things where the position of the actor is not actually like the position in the world that the movement controller wants. Because it depends. We might. It's a platformer. Physics are going to be a big part of the game that we need to get right. So again, if actor is null pointer, let's just return the f vector 0 vector. Is that what it's called? Let's just double check. Is this the vector? This is for speed tree. No, we want the Unreal vector. And yeah, there it is. It is 0 vector, so we're not being absolutely insane. Just a little bit insane. Current velocity. Well, I see there's 10 people watching or something like that. You can say hello if you want. You can ask questions. I'm working on Dashkin. This is a game in partnership with Adam Phillips, who I don't think anybody knows who I am, but some people may know who Adam Phillips is. He made the Bitey of Brackenwood series, and our game we're working on is a 2D speed-based platformer in Unreal. 2D in that, all the movement and stuff like that, I'm pretty sure we got locked down to 2 dimensions, but we'll have 3D elements in there because we got 3D engine. Let's use them. Let's use all the elements. So if you have any questions, throw them in chat, and I'll do my best to answer them within reason. And if you have any requests, such as, well, how does this work, or how does that work? Well, I'll do my best to answer it if I know, or just say, I have no clue. I'm not going to claim to be super expert man on things, but I'm at least an expert on my own version of madness. Previous position. Get previous velocity. Yeah, let's snag that. Which also means my set velocity, I probably want an internal set velocity. Just so we don't ever frickin' forget about setting it properly. And then all the stuff that requires the previous velocity to be accurate gets just screwed up, and we don't know why. So at least we don't have to check for null on everything on this one. Alright, set velocity is there. Previous position, that's also very easy. We should probably throw those next to each other. Why aren't they? Let's clean that up a little bit. All the position stuff and velocity stuff should be right next to each other. Seems reasonable. Alright, previous velocity. Set our maximum velocity. Well, we don't have maximum velocity, do we here? So why don't we just go ahead and make one? Let's also kind of separate this out here. We might be throwing things like maximum velocity off into some other thing where you kind of attach it to the object and then can edit it and all that sort of stuff. So it might be somewhere else. So let's just do that. I was just googling real quick what the syntax for max is for float. We'll just let you go the speed of light, or at least close enough to it that it'll break every piece of physics we possibly can. So if we're setting our maximum velocity, we're also going to want to take our actual velocity and set it, clamp it, and that same thing. So let's see, if velocity is less than our current max velocity, then let's go ahead and take our, we're gonna have to do a couple things here, aren't we? Should we just call set velocity with our current velocity? And basically set velocity is going to call, we're going to have to check if our the magnitude of this velocity is greater than our maximum. So is it size? Yeah, we'll just do size is less than max velocity. Then velocity equals velocity dot normalize. Is there normalized? Let's check. No, whatever, let's just do velocity dot normalize. And then we're just gonna say it's times max velocity. So that should clamp us to what we want to do. And there's probably a square root thing there that we could optimize, but we can always optimize stuff later. I just don't want to be squaring big floating point numbers and overflow things. Alright, so set our locomotion type. Should probably just call this set movement type, because we called the enum movement type, so. Just kind of follows that that's what we do. We'll probably have more stuff in here later. Like if a guy goes from standing to flying, we'll probably have to do something with it, like play an animation, or at least check if there's like a transition animation and then play the transition animation and then have like a wanted movement state and all that other crap in there. But we'll see. So I need a movement state. set. What about our set movement state? Where is that? Oh yeah, we are setting that, so we're gonna need a private set movement state, probably. And we might have to do a few things in that set movement state, like change some animations. Not sure though. Get there when we get there. Let's see, where is that enum that I set up? I mean, that static thing. Should do that. Get movement states. Jump. Well, we'll need to do this. Not exactly sure. Basically, I guess we'll be adding our. So we should probably check if we're. Well, yeah, we should add the velocity to our current velocity, and we should check our movement state. Check our state. If we're on ground, then we need to play the jump animation, and let's see, else do nothing. So we'll see how that goes. Alright. Set wanted location. Or location and velocity? Alright, yeah, this is just the wanted location. So, okay. Wanted. We don't have a wanted location. We should probably have like a wanted direction, a wanted location, and all that, just for the sake of clamping to something. So if you're like, yeah, I want to move to the right, but no more than a certain amount, nah, we probably don't need to complicate it that much. And wanted velocity, like if we're passing in a float for our velocity, which is just a single number, how are we going to translate that into a vector? I mean, should we just take our current position and then make a velocity based off of that? So it'd be like a vector position equals get position, right? Just make sure. Let's grab our position, and we're gonna do. Let's just do direction. So we're going to dir. What's gonna be direction equals location minus. Let's just do get position. Let's make it code simple. We don't need to optimize this stuff before we're using it. So what we're gonna do is dir.normalize, and we're gonna say wanted velocity equals direction times velocity. And that should do it for that. Set wanted location, wanted direction. Yeah, so all we're gonna do here is call set wanted direction, and we're gonna do let's normalize it and just do direction times velocity. Wanted direction. So this is just direction. Okay, so wanted direction equals direction. Direction normalize. And then wanted velocity equals direction times velocity. And this guy we don't know, so we're going to do wanted direction equals direction. We're going to normalize just set that up there. Oh yeah, well. Normalize there, and then go like that. Because it's const, we can't change it. We shouldn't change it. That's why we made it const. Let's see, so wanted velocity. Well, this is just setting our wanted direction. So we should just set our wanted direction and not our velocity. Why do we have direction and velocity? I think maybe we should just be setting velocity here. So we should, this is just stupid. Set wanted velocity. And then it should be direction and velocity. And then we're just doing, yeah, it's just dumb. Wanted direction and velocity. Direction is just let's see, set wanted. That looks more like what we want. And then let's throw like a real basic like Dashkin direction. And we can just say like DD left and DD right. And then when we're working on other stuff, we can just say, oh, I want to go left and I want to go at this speed.